Okay, so we looked at section 7.1, which was on the empirical rule, and that should have got you ready for the first quiz. And these next two worksheets will get you ready for the second quiz. I've already set this up for us. This example tells us that we have a mean of 74 and a standard deviation of 8. And if I drew my curve, as I showed you how to do in the previous videos, we can see here that the middle would be 74, and then adding to the right, 1, 2, 3 to the right, and then 1, 2, 3 to the left. Also going to introduce this idea of z-scores today. So if we call 74 the middle, we're going to call that ground zero. And if I move to the right, 82 would be 1, 90 would be 2, and 98 would be 3 steps to the right. And if I go to the left, we'd be subtracting -1, -2, and -3. And we call these a z-score. It's another way of describing your position on a distribution. So I could say if you got a z-score of 1 on this test, you scored an 82. And if you got a z-score of -2, you scored a 58. And if you got a z-score of 0, which normally is a bad score, you actually scored average, 74, so it's not such a bad thing. So we're going to learn how to use the calculator today. And if you don't have a calculator at home, I posted a link for two different calculators. One is the TI-84 you can get for $6 for free. It's like the one we use in class. And then I also am going to post a link for one you can get for your phone or your iPad. So what I'm using today. If you need help with that, you can message me. So the first question says, it's going to be a lot of calculator work today. What is the probability that a person will score below 80? So the notation we use is probability P, that x is less than 80. So to do that, we're going to use what's called a normal CDF function on our calculator. So I'll show you where to find that. Normal curve, CDF means cumulative density function. And we want to know what's the probability that your score goes from 0 to 80. So the first two values you put in are the values that we're looking for, from 0 to 80. And then we have to put in the mean every time. So the mean is 74, and the standard deviation in this example is 8. These are always going to be the same, at least for this model. Now, so if we're going to look at this in terms of a picture, 80 would be somewhere about right here. And we want to know what's this probability. Obviously, it's going to be greater than 50% because the probability that you score below 74 is 50%. So it's going to be something greater than that. So how do we get that answer? Well, I will show you. I'm going to go to our calculator. This is one of the calculators. And you can see I've already done it for you, but if I'll show you how I got that, we're going to press second and then vars. And we use number 2. And 0 is our lower bound. In this case, that's the lowest score you can get. 80 is upper bound. And for our distribution, the mean is 76 and the standard deviation is 8. And that comes out to be 0.69. So our answer to that question is 0.69, which would be 69%. Okay. What's the probability that a score is above 70? So in this case, we're asking what's the probability that your score is above 70, so 70 or more. So again, we're going to use our normal CDF. But in this case, we're starting at 70 and we want to go up to the highest score. So the highest score in this model is 100. And again, our mean is 74 and our standard deviation is 8. We looked at a picture of that. 70's here, and we're going this way. It looks like it's going to be probably about the same. So go back to our calculator. Again, second function, distribution. We choose number 2. We're starting at a score of 70 or above. So we want to know how many people. We have to put a comma in between. The highest score you can get on the test is 100. And for this, 76 and 8. And so that came out to be 77%, 0.772. Let's go back and record that. 0.772 is 77.2%. All right. What's the probability the score falls between 70 and 80? So we're looking at this area in between 70 and 80. And so we can use the calculator. We're going to say probability that 70 is the low score and 80 is the upper score. And again, normal CDF. We want to start at 70 and go all the way up to 80. And the mean is 74 and the standard deviation is 8. So this is a video, so you're going to be able to go back and stop it if you need to. So we're going from 70. This is a lot easier than the way we did it when I was in school. We had to use tables and such. It's a lot easier. Again, you can get this calculator for free. I can give you the link. So it's 0.4648. So this is just like what they do in my AP class. Okay. Waiting for my screen to come back. Technical difficulty, but still recording. All right, so 0.4648, just like in the classroom, right? When my Apple TV crashes. All right, so that's using the cumulative density function for what we call a left-tailed test. The second one is a right-tailed test, and this one is an in-between test. Very common way of using the function. The second part to this is, what if we knew the percent and we wanted to go backwards and figure out their score? So to do that, it's a pretty easy function. We're just going to use the inverse function. So in this case, we're going to use what we call the inverse normal. So we want to know, suppose I said you scored in the top 20%. So that means you're way up here, right? What's your score? Well, the top 20% is going to be somewhere up, probably above 82, above 80 at least, right? So we're going to go and use the calculator to tell us what it is. So we're going to use a function called inverse normal. So it's inverse normal. And all we have to put in is the percent, and then as with the other function, the mean and the standard deviation. So 76 and 8. And we find that function in the same place that we found the other one, second bars, except we use the third one. And we're going to put in our top 20%. Now, I made a mistake here because if I'm in the top 20%, that means I'm ahead of 80% in the class. So I actually have to go back and change that to 80% because I asked for the top 20%, which means you're in the 80th percentile. So I'm going to fix that when I go back. So 0.8 and 76 and 8. You can only do the inverse normal from the left to the right. So that means that your score has to be an 82.73. I'm going to go back and fix that here. My iPad's taking a while to sync. So the top 20% would be, so this would be 80% on this side, and this side is 20%. See what I mean? So we always measure the left side. And this came out to be, I forgot this number, 82.73 is what we were looking for. So your score would have to be, waiting, there's some sort of lag here, 82.73. All right, let's do the last one. So we're going to convert 90 to a z-score. So to do that, we need to have a formula for z-score. And our formula for z-score is how far away is it from the mean divided by the standard deviation. So to do that, it's pretty easy. Z-score formula is your score minus the mean divided by the standard deviation. So in this case, your score was 90, you're above average. The mean is 76, and we're dividing by the standard deviation, which is 8. And if we subtract those, we end up getting 14 divided by 8. Use our calculator here. 14 divided by 8. We get 1 3/4 or 1.75. I don't know why it gave me a fraction there, but my z-score would be 1.75. That means you're almost 2 standard deviations above average. And the opposite is we can convert this back to x. So if we're going to solve this formula for x, this formula, x represents your raw score. X is going to be equal to z times the standard deviation plus the mean. So in this case, we want to solve for x. It's going to be negative 1.1 times 8 plus 76. All right, so let's do that later. Negative 1 times 8, clear. So it was, let's back at our formula. Negative 1.1 times 8. I had a mind problem there. So it's going to be negative 8.8, basically. So negative 1.1 times 8. So that's the number of standard deviations, times the actual standard deviation, plus 74, which is the mean, which means your score would be 65.2. We're doing 2 days of this, so don't worry if you didn't get this first part. Okay. All right. I'm not going to ask you to do this, but in class, to use a table, we could use the table to convert these back to values. We could actually also use a calculator, but I'm going to not go through this part today. I may come back later and do this part of using tables, so don't worry about this part. All right, so that is our first day with z-scores.